Hello students, welcome back to maths class. So we are doing integration chapter. It takes 10 days I think. It is lengthy, but remaining two topics are based on this one, so concentrate more on this integration. Not only next two chapters in your further studies, that means in degree and in engineering also, this is calculus is very crucial topic in mathematics. Wherever you go with the mathematics, it follows you. Okay, so come on. Now today which topic we are doing means integration by the method of substitution. So previous two classes we have taken small problems. They will be in our direct formula form and we solved it easily, right? Now suppose instead of not a direct form, indirect form is given to you. So by using substitution method we can solve that problem. What is this substitution means? In that question, instead of one value we will take in place of that one we will substitute another value, so that our entire problem will be in our standard form. Okay, so see, integration by the method of substitution. In this method we reduce certain integrals to some standard forms. At the end we should get our standard form so that we can apply the formula. So if the problem is not in standard form, by using this substitution method we can get it into our standard form. By useful or suitable substitution we will get the answer. So first one or two problems, it looks a little bit different for us. This is new method, but slowly you will know, you will get idea which value should be taken as substituted value. Okay, so come on, first question. See, what is that? Find the integral of 6x by 3x square minus 2 into dx. So observe, there is no standard form in it, right? Only x values are there, only 1 by x is there, only sin x, only cosec x. We can take the values, but here some values are there in numerator, we are having in denominator, we are having the value. So how we can take? Observe, this is, suppose instead of this if we have taken t, if we differentiate we will get another value. In this substitution method, if we take one value as a t and we solve that problem, finally it will comes into our standard form. How? See, here I will take, in this substitution method we will take t is equal to 1 of any value of the problem. So we are taking 3x square minus 2. So here you can ask one question, why you have taken 3x square minus 2? Why not 6x? Right? I will show you why I have taken this one. So now differentiate with respect to x on both sides. What happens? dt by dx is equal to d by dx of 3x square minus 2. So see, I said no, differentiation formulas also comes. So once you go through the differentiation formulas, then substitution method will be very easy for you. So in the differentiation, whenever plus minus is there, what I said, we have to take separate derivatives. So it is d by dx of 3x square minus d by dx of 2. So whenever constant is there, we will write outside d by dx of x square. Whenever only constant, derivative of constant, you know it very well, it is 0, right? So 3 into d by dx of x square is 2x. So 3 2s are 6 into x. So which value we got? dt by dx is equal to 6x. Send dx that side, what happens? dt is equal to 6x dx. See, we have taken this as a t and we got this as dt. That's why we have to take this one. Why? Means if power is more, if we differentiate that value, right, power will be reduced. Its power is 2, its power is 1. Whose power is more? This value's power. So you know it very well. What is the formula? d by dx of x to the power of n is n into x to the power of n minus 1. So its power will be reduced by one value. So here your power is 2. Here its power is reduced by one value. That's so if we take this value as a t, if you differentiate it, you will get this value. That's why we have taken t as this one. So in any substitution problem, two terms are there. You take that term as a t whose power is more than of that one. That too only one. See, here power is 1, here power is 2. It is reduced by one power. So this is higher by one value. Like that, that value, which term is having higher power, that should be considered as t. Okay, so you got dt is equal to 2x dx. So therefore you take your problem, what is that, 6x dx by, come on, 3x square minus 2 is equal to integral, what is your 6x dx? It is dt by, what is this value? We have taken that as t. So we can write this as 1 by t into dt. See how nicely it comes into our standard form. What is the standard form? At the end of the problem, we will get the problem into our standard formulae. Integral 1 by x dx formulae is equal to log x plus c is the formula, standard integral formula. Instead of x, we are having t, right? So in the formula, instead of x, we will take t. So log t, once integration over, we have to write plus c is equal to log of, what is the t? We have taken t as 3x square minus 2 plus c. That is the answer. Okay, so this is called substitution method. Whenever problem is not in standard form, and if we observe that problem, if you have the differentiation knowledge, you can see that one value if we take as a t, if we differentiate, we will get another value. In such cases, we will go for our substitution method. Okay, so now come to the second one. So once after copying these problems, once you open your first year notebook and go through the differentiation formulas, right? So only in a substitution method we are going to use this differentiation formulas. So come to the second question. Find the integral of, come on, sine inverse x by root of 1 minus x square dx. So observe carefully. If we take one value as a t, we should get another value as a dt. Then it will be in our standard form, right? So can we write this problem as sine inverse x into 1 by root of 1 minus x square dx? Can we write? Yes, we can write definitely. So now you take your t is equal to sine inverse x. So what is the derivative of sine inverse x? Differentiating with respect to x on both sides. dt by dx is equal to d by dx of sine inverse x. d by dx of sine inverse x is 1 by root of 1 minus x square. So we got dt by dx is equal to 1 by root of 1 minus x square. What will be dt? Send dx that side. 1 by root of 1 minus x square into dx. Isn't it? So now you take your problem. This is your question. Isn't it? So come on. Integral sine inverse x into 1 by root of 1 minus x square into dx. So is equal to integral sine inverse x we have taken as a t. So t and this value is dt. So this value is your dt. So we can write this as t to the power of 1. Which form? Simple form, x to the power of dx. So it is of the form integral x to the power of n dx. Power means integral x to the power of n form. X to the power of some power is there. We have to go for this formula. Instead of n, you can have any power, positive or negative. So what is its formula? X to the power of n plus 1 by n plus 1 plus c. I said most repeated formula. See how nicely your problem turned into your standard form. So it is t to the power of 1 plus 1 by 1 plus 1 plus c is equal to t square by 2 plus c is equal to, what is your t? At the end of the problem, we have to substitute again t value. Why? The question is in terms of x. Answer also should be in terms of x, not in terms of t. Okay, the question is given in terms of with respect to x. Answer also should be in terms of x only. So what is your t? Sine inverse x. So sine inverse x whole square by 2 plus c. Right? So this is your answer. This is your second question. Right? So substitution method. Observe first one and second one. If you know the differentiation formulas, if you have the idea of differentiation formulas, you can enjoy with these substitution problems. Okay, so better once you go through the differentiation problems from your first year notebook. Okay, now we will go to the third question. So read the third question and come on, try to get the idea of which value should be taken as a t. Observe that question carefully. Slowly with the practice and by doing these problems, you will get the idea which value should be taken as a t, so that it will turn into your standard formula form. Come on, come to the third question. Find the integral of x to the power of 5 by, what is that? 1 plus x to the power of 12 into dx. So observe how we can convert this problem into substitution method. See, can we write this as x to the power of 5 by 1 plus, can I write this as x to the power of 6 whole square? Yes, definitely we can write 6 to the 12. So we can write x to the power of 12 as x to the power of 6 whole square. Why we are writing like this? So if I take t is equal to x to the power of 6, what happens? If we differentiate it, you will get your x to the power of 5. In the first question, I said to you, if in two terms, one value power is more than of one value, take that value as a t. If you differentiate it, one power will be reduced, isn't it? So here we are having x to the power of 6. Here we are having x to the power of 5. So if we take this one as a t and differentiate, definitely one power will be reduced. Why? We know the formula d by dx of x to the power of n is equal to n into x to the power of n minus 1. One value of the power will be reduced. That's why you take t is equal to x to the power of 6. Differentiating with respect to x on both sides, what happens? dt by dx is equal to d by dx of x to the power of 6. So what happens? X to the power of 6 means x to the power of n form, 6 into x to the power of 6 minus 1, 6x to the power of 5. We don't want 6. We want only x to the power of 5. Why? In the problem, we are having x to the power of 5. So send that 6 this side. So it will be 1 by 6 dt is equal to x to the power of 5 dx. See how nicely we got the value. So therefore, integral x to the power of 5 dx by 1 plus x to the power of 6 whole square, right, is equal to, it is 1 by 6 dt by 1 plus t square. In the integral, if number is there, it is constant, we have to write outside. So you take outside, so now it is 1 by 1 plus t square dt. Your standard formula, integral 1 by 1 plus x square dx is equal to tan inverse x plus c. So formulas I have given in terms of x. So x is general term. Instead of x we can have any value. So here instead of x you are having t. So your formula also in terms of t only. There it is 1 by 1 plus x square tan inverse x. Here it is 1 by 1 plus t square tan inverse t. Right. So is equal to 1 by 6 tan inverse t plus c, okay, is equal to 1 by 6 tan inverse. At the end I said we have to substitute t value. Our answer should be again in terms of x only. Question is with respect to x. Answer also must be with respect to x. Don't forget. Here integration over, I have taken plus c. That's why it is completed. No, not completed. In t place, we have to substitute its original value. What is the value? X to the power of 6 plus c. That is the answer. Okay, so actually we are getting the answers very smoothly, right? After that I am writing like this and I will feel happy. Same thing will happens with you only, right? With these integrals. Once first 2-3 days it will be little bit difficult. Why means for your brain formulas are very new and very different, right? Slowly if we used to the formulas then it will be very easy, right? So come on, next we will go to the next question. What is that? Fourth question. Observe the fourth question. So we are doing substitution problems, no? So you have to observe which value should be taken t, so that entire problem will be comes into formula form. So come on, see your fourth question. What is your fourth question? So it is find the integral of cos cube x, right, into sin x dx. So how we can write? Cos cube x can be taken as cos x whole cube, both are same, cos x whole cube into sin x dx. So already I said to you, whenever power is more for the value, that value should be taken as t, right? So you consider t is equal to cos x, right? Then differentiating with respect to x on both sides. What happens? It is dt by dx is equal to minus sin x. But here we are having only sin x. We don't have negative sin x. So give that negative sign to this side, or multiplying both sides with a minus sign. So minus dt is equal to sin x dx. See, you got this value. Okay, so with practice, just by seeing the problem you will know it. With practice means first if we solve 3-4 problems, 6th problem, 7th problem, you will get the idea. Your brain will take that concept, that logic. Okay, so is equal to integral. In this cos x we can take t, so that is t cube. What is sin x dx? It is minus dt. So we can write minus sign outside. Minus dt means minus 1 into dt. So we will write that as outside, minus 1 as. So it is t cube dt. Which form? It is x to the power of n form, isn't it? Instead of x you are having t, and power is there. So whenever any value is having power, you have to go for that formula. Integral x to the power of n dx. What is that? X to the power of n plus 1 by n plus 1 plus c. So is equal to minus of, in x place we are having t. So in n place we are having 3. So 3 plus 1 by 3 plus 1 plus c. So is equal to minus t to the power of 4 by 4 plus c is equal to, come on, what is our t? At the end we have to substitute our t value, that is cos x to the power of 4 by 4 plus c. That is the answer. We'll write one smiley also. We got our answers like that, isn't it? So come on, very simple. Just if you do 3 problems, 4th problem, 5th problem, you will get the idea which value should be taken as a t, so that our problem will be converted, turned into standard form. See how nicely it comes into standard form, x to the power of n form. Here it is 1 by 1 plus x square dx form. Like that, at the end your problem will be one of your standard formulae form, so that we can apply that formula, and after that we have to substitute t value in it. Okay, so now come to the 5th question. So what is your 5th question? Observe. So it looks little bit complex now, but it is not complex. Okay, so don't judge by seeing the question. Okay, so take the question, 5th one. What is that question? Integral 1 minus 1 by x square e to the power of x plus 1 by x dx. So what is this, madam? It is e to the power of x is there, and x 1 by x. So many things are there. So how we can take this problem? So can we write this problem as e to the power of x plus 1 by x into 1 minus 1 by x square dx? Definitely we can write. These are product form. That means they are in a into b form. We can write b into a also. There is no wrong in writing a into b as a b into a according to our situation. So why we have taken like this? See, you take t is equal to x plus 1 by x. Differentiating with respect to x on both sides. What happens? dt by dx is equal to d by dx of x plus 1 by x. Okay, so is equal to, whenever plus minus is there, we have to take separate derivatives. So it is d by dx of x plus d by dx of 1 by x. So d by dx of x is 1, you know it very well, and plus d by dx of, we can write this as x to the power of minus 1. We don't have any direct formula of d by dx of 1 by x. That's why we have to take like this. So 1, and you know the formula, d by dx of x to the power of n is n into x to the power of n minus 1. So come on, here in n place you are having minus 1. So minus 1 into x to the power of n minus 1 minus 1 minus 1 is equal to 1 plus of minus minus x to the power of minus 2. We can write this as 1 minus 1 by x square. See, your dt by dx is this one. Send this dx that side. What happens? dt is equal to 1 minus 1 by x square dx. Observe the problem. So we have taken this as a t, and we got dt as the other value. So if you have taken x plus 1 by x as a t, if you differentiate it, you got 1 minus 1 by x square dx as dt. So therefore, substitute in the problem now, e to the power of x plus 1 by x into 1 minus 1 by x square dx is equal to integral e to the power of, we have taken that as t, and we got this as dt. See how simple formulae form it turned, isn't it? You know, integral e to the power of x dx is equal to e to the power of x plus c, right? So these formulas are with respect to x. There x is general term, instead of x we can have any value. So here it is in terms of x, e to the power of x plus c. It is in terms of t, so its value is e to the power of t plus c. Now you substitute your t value here, e to the power of t. Which value we have taken? X plus 1 by x plus c. That is the answer. Okay, so e to the power of x plus 1 by x plus c is the answer. So in this problem, remaining problems, just by seeing that you will get the idea. If we take cos as t, if we differentiate we will get a sine. If we take 3x square minus 2 as a t, if we differentiate one power will be lessened, so it will be 6x. But in this problem you should be little bit careful. So but they don't change the problem in final exam, no. So once you practice you will remember which value should be taken as t. Okay, these are all selected questions, so you have to practice perfectly, right? So don't skip any one day's maths class, right? And don't skip the practice also. You have to watch, you have to copy, you have to practice, then only you will get your maths perfectly. So come to the sixth one. What is that sixth one? So just it is homework. I will explain to you how to solve this one. So very simple, you take that one as c. We can write this as, how we can write, sine to the power of 4x by cos to the power of 4x into 1 by cos square x dx. Can we write? Definitely. Cos to the power of 6x can be taken as cos to the power of 4x into cos square x. So both are having same power now. You take power common. Sin by cos is tan. So tan 4x, and 1 by cos is secant, square is there. So it will be secant square x dx. So very simple. You take t is equal to tan x there, right? So then its dt will be secant square x dx. So you will get t to the power of 4, right? So integral t to the power of 4 is t to the power of 4 plus 1 by 4 plus 1 plus c. At the end you substitute t, you will get your answer. Okay. So these are some substitution problems today we did. So just with the practice you will know which value should be taken as t, so that at the end your problem will be turned into one of our standard formulae form. So by using this substitution, our aim is to convert the problem into our standard form, and applying the formula we will get the answer. Okay. So practice the problems. That's all for today. Have a nice day.